Okay, so Naizen, I would like to begin my talk titled Joy Wells 3D Graphics using Ruby. Thank you for coming in my talk. Okay, in here, I'm very honored to be able to give my talk at Ruby Conf Taiwan today. Thank you so much for accepting my proposal. And it's my first visit to Taiwan, and I have come to love Taiwan very much, and so very nice food and very nice beer, and yeah, Taiwanese beer is very nice, yeah. And let me introduce myself. I'm Yudai Takada, and my GitHub and Twitter is this IDs. So, but a lot of Rubyists call me this IDs, so but a little bit difficult to pronunciation. So you can call me Wider, as you can call me Wider. Yeah, please call me Wider. And I'm an open source software programmer, and the Celo Megameter mainly develop browser-related features. And a committer of Ruby Liamers. This is a LLR browser generator. And yeah, I'm from Osaka, Japan, and my house is nearby Osaka Castle. And yeah, and I'm a chief organizer for Osaka and Kansai Ruby Kaigi. And this year we held in Kansai Ruby Kaigi 08 in Kyoto. And next year we will hold in Shiga Prefecture, so please come if you are interested. Yeah, and I'm a co-founder of Kyoto Ruby with Hudson. Yeah, and if you ever visit Osaka, please come and join us. Yeah, let's drink. Okay, so today's talk is Joy Wells 3D graphics using Ruby. So I'm talking about 3D graphics and not a parser. Yeah. And today I will introduce several sample codes. So if you would like to actually run these sample codes, I have placed all of today's code at this QR code. So, so please try running them if you are interested. Yeah. And yeah, so first, currently there are mainly 4 options for rendering 3D graphics. And yeah. This is like OpenGL. OpenGL is it works anywhere, and it's traditional and it's generic API. And the DirectX. DirectX is a Microsoft platform specialization, and the Barkan. Barkan is a spiritual successor to OpenGL, a low-level API for fine control of the GPU. And the Metal is also low-level and low overhead. Hardware accelerated 3D graphics and the compute shader API created by Apple. And today I'm going to talk about OpenGL. Yeah, what is OpenGL? OpenGL is an open graphics library, is industry standard API for hardware independent 2D and 3D graphics rendering. And it's cross-platform, and it is used a wide range of fields, like from visualization, scientific, and technological calculations to game development. And in recently library for working with OpenGL in Ruby, I'm recommended to use OpenGL binding too. And there is an offshore wrapper, but I don't recommend it because it failed to install the gem in the latest version of Ruby. And so looking at the commit log, the last commit was 7 years ago. So yeah, it's understandable. And yeah, leading sample code tips is the writing style is completely different before and after OpenGL 3.0. So be careful. And it is better to understand which style is written before reading. Yeah, and in the old styles, Batik data is sent one by one from the CPU to the GPU and drawn between the instruction block 0 begin and 0 end methods. And in the modern standard method, the Batik data is transferred to the memory areas on the GPU called Batik buffer object, and the shader is executed on the GPU. Which allows fine control of the drawing process. And OpenGL is just a graphic engine, so there are things it cannot do on its own. So this create window and handle keyboard and mouse input and create an OpenGL context like a drawing environment is not do. So instead, libraries such as GLFW and GLUT provided those functions. So libraries GLFW and GLUT as libraries that provides the peripheral functions needed to use OpenGL. So it's also abstract the OS specific processing. And yeah, one more time, OpenGL is a drawing engine, and the GLFW and the GLUT is a toolkit to interface with the platform. Yeah, first I'm explaining about GLUT. GLUT is the OpenGL utility toolkit, and our library developed in the 90s that feature simple API, and they provide windowing and event handling and basic drawing functions. And this is good for running, but no longer development. So the original GLUT haven't been maintained for over 20 years. So this is a official page. So the dimensions, we direct you to free GLUT found in the source for the original GLUT have been unsupported for 20 years. So this is a very old toolkit. So if you can use GLFW is recommended. So this is a graphic library framework. So more modern libraries introduced in 2002, and the support for multiple windows and the monitors, and the final event control, and the support for OpenGL 3 and 4 and the Vulkan and the Metal and other modern APIs also supported. Okay, so getting started with GLFW is if you use Windows, gets binary from this page, and if you're using Mac OS and Linux, you can get a package manager like Brew and apt install. Okay, so let's start drawing 3D graphics. So in the first, we need to create a window. So this is a sample code for create a window. Load the GLFW library and initialize GLFW library and create a window. This is first and the second argument is Windows size, and the third argument is Windows title, and this is a main loop. Result is here. Yep, just to create a window. And I'll introduce another useful GLFW feature that's good to know about the callback registration. This is helpful when you want to make changes to what you are rendering. For example, when a certain key is pressed or when there is mouse operation. So, yeah. And this sample code is this menu is close window when escape button is pressed, and yeah, set callback to window, and in the main loop for event. Yeah, it's very easy. And now let's actually start drawing polygons. Before that, I'll explain some useful knowledge to know positional information. So internally, OpenGL uses 4 pieces of information to manage the position of a single point. This is a homogeneous coordinate, x, y, z, w. And maybe you will probably think, why do you need 4 pieces of information in 3 dimensions? This is a for smooth computation of projections. So we need to 4 information for 3D dimension. And there are generally 2 types of coordinate systems. And yeah, one of a right-handed coordinate system is a positive in front of the z-axis and negative in the back of the z-axis. And another one is a left-handed coordinate system is negative is front and the positive is back to the z-axis. So OpenGL is a right-handed coordinate system. So positive is front and negative is back of the z-axis. And now we give a positional information to vertices for rendering. But when OpenGL draws something, it renders in units called primitives. So we need to define basic unit of what to draw. And the types of primitives is include points and lines and polygons. It's defined as a collection of vertices with positional information. Okay, so let's review once more what is needed for rendering. First define vertices. This geometry consists of coordinate x1, y1, z1, and x2, y2, d2, and blah blah blah, and teach vertex position information, and define primitives. Draw a triangle using a previous vertex and specify the type of primitives. And finally, rendering. Rendering is a convert defined primitive into a form that can be displayed on the computer screen. Okay, so let's start by drawing something simple polygons. So first, this is a draw triangle sample code. Okay, so first we need to declare to draw a triangle. So this is a primitives. So draw triangle is primitives. And defining coordinate for 3 vertices, and signal that you have finished drawing the triangle. So this sample code result is here. So we can draw a white triangle for now, but you will probably want to add color to this triangle. Okay, so let's add the color information. This is just adding a color 3F method. So specifying red and blue and green colors. This sample code result is here. Okay, so red and blue and green. And so you can draw a rainbow triangle just by specifying the color of the 3 points. And after adding color, you will probably want to add so you can draw a rainbow triangle just by specifying the color of the 3 points. So this is automatically interpret the color of each vertex. Yeah. So okay. So but after adding color, you will probably want to add animation next. Okay, so let's add the animation. So this is changes at the rotate F method. This is a rotate 1 degree around the z-axis. And yeah, so this is the result, but it seems it's good to yeah.
The Windows full screen, so you might want to get out of full screen mode.
Okay. どこだ?
It should be in a different window.
Okay. Yeah, this is results. Yeah. So, yeah. So, it's not rendering as expected. What was thrown to be a triangle has become a circle. Yeah. So this is a reason for we need to clear screen. So this one iteration of this main loop corresponds to 1 frame. So we need to set the screen clear color to black and clear previous frame drawing. So after that, yeah. With this, we can add color and draw triangle and add animation too. Yeah. So, okay, so but I want to draw in a 3D graphics, so this is a 2D graphics. So let's draw a cube. So we need to draw a 6 face because of cube. So primitives is quad and is different 6 color, and we specify the 4 vertex and so each faces. But this result is here. This isn't a good drawing. It's because we need to knowledge for 3D, so perspective projections. So this is the equivalent of camera lens and determines how 3D space is projected onto 2D screen. We need to field of view and new creeping plane and the far creeping plane we need. So we need to setting the projection matrix. And this is a sample code, and yeah. First, computing Windows aspect ratio and tells OpenGL that the matrix operation is projection matrix, and resets the currently selected matrix to the identity matrix, and sets the vertical field of view to determine how wide the camera can see, and determines the boundary beyond which objects are not drawn. And finally, calculate the near creep plane position information. And finally, projection matrix for perspective projection as generated and set. And we need to another matrix. So we need to set a model view matrix. This is in 3D graphics. Matrix use transform an object's coordinates in the world space into camera space. Model matrix is for transforming vertex data based on position and rotation and the scale in the world coordinate system. So previously I'm rotate triangle. So rotate is also model matrix. And another one is a view matrix. View matrix is for define the position and orientation of the camera and transform world space coordinate into camera space. So we need to setting the model view matrix. And this is a sample code. And yeah, declare that we are about to operate in the model view matrix and initialize the matrix. And move the camera back 9 in the positive z-axis. And animate by increasing the rotation angle by 0.5 degrees each frame. So this is the result, but yeah, okay. Okay. This is sample, but this is something's wrong again. So yeah, so this reasons is this is also setting the clearing frame for and the clearing depth. So under setting depth. So we need to add this code and first draw object in the foreground to properly hide object in the background, and we need to clear color and depth information for each frame. And so okay, so yeah. Yeah, and here is the result of running the rewriting sample code. So I was able to render a cube and rotate. Yeah. And but yeah, it is so good. But we need to find a one shot. Find one shot is the lighting and the materials. So we can now display 3D object on the screen in the correct position and the shape, but it still looks like a flat and shadowless pictures. So the last important element that adds reality is lighting and materials. So they simulate how light bounces off the surface of an object and reaches our eyes. So this is a sphere's example. The left side looks like a very flat circle, but the right side has lighting and material setting. So I think it looks like a very three-dimensional spheres. And light is three types of light source. Well, first is specular reflection and diffuse reflection, and finally ambient light. So we need to set three types of light source. Ambient light is indirect light that illuminates the entire surface evenly, and help prevent shadows that do not shine directly into the light source from going black. And diffuse reflection is reflection where light from a source scatters evenly across the surface of the object and determine the brightness of illuminated surface. And finally, specular reflection is a light source that reflects strongly in a particular direction, and this is produce a gloss. So we need to add this sample code. Yeah, this is a lighting and material setup code. First, enable lighting, and enable those light among the available light sources. And automatically normalize phase orientation vectors, so lighting is computed correctly after scaling. And set the three light sources, ambient and diffuse and specular. And use the color specified by dual color 3F as the object, ambient and diffuse reflectance coefficients. And sets the object specularity and grossness. And another one is setting the model view matrix. This is sets right source position after camera movement but before object rotation. And finally, sets normal vectors. This is specify a normal vector for each face to correctly calculate lighting. So this is result is right side. So maybe since it's a cube, so the difference might be very small. But while the left side has no shadows in the yellow side. So and the right side has shadow, and I think achieves more three-dimensional representation. So yeah. Okay, so finally, so I would like to introduce my work that I created using the techniques introduced today. Yeah. This is my work. So this is Ruby and Type A. 1.1, yeah, and and press button and change the forward, and left and right button pressed. So rotating Ruby. This is rotate right and rotate left, yeah. So today I'm introduced so all sides. All side open side way, but this so simple 3D graphics is very good, very enough for all sides. So yeah, so. So conclusions, Ruby and OpenGL make it easy to draw 3D graphics, and it's also a great way to learn the basics of 3D graphics. And the world of 3D graphics is a deep and exciting field to explore. So I hope this talk will be your first step into the exciting world. So thank you so much.
example, very nice work. Your example, first example of the triangle example, that is color is assigned to the vertices, but later example, the cube example is the surface, which is a different. What is the difference?
So first example is specify the color with each vertex, but cube is specifies one color for us for vertices. So this example is so using three colors in one primitive. But second cube example is using four vertices but one color. So it is so different from this example and the cube example. Yeah. Thank you.
Did you manually calculate the vertices for your last example? Like, I think there will be 100, 200 vertices, or in your tower animation.
I'm not yet count, but but maybe so. This example is so. This demo is not too complex. So yeah. So maybe. So sorry. I'm not calculate the how many vertices in this in this demo.
If it is possible, I think sharing the code, number of the line in the code is
I see.
to understand why it's complex or not.
見れるか。Yeah, maybe under the 600 line. Yeah. So I'm update to this demos code into the into this repository. So you can see the this demos code. Access in this this QR code. So you can see the all of sample code for today.
Thank you, Desan. So if there are no other questions, we're going to have 5 minutes break. Okay? ありがとうございました。